this is basically the wiring diagram. This is the shore power. The shore power double phase receive the phase 1, phase 2, and neutral and ground coming from the transformer at the beginning of the dock. Once again, this is the AC switch selector. AC switch selector. You remember in DC, the red one? That's the DC switch selector. Battery bank number 1, battery bank number 2. This is similar, but this is for AC. Shore power, generator, and inverter. Those are the three sources of AC power. Okay, and this is the common. This is the output. The output in this particular case, because it's a double phase, is entering in the isolator transformer. The isolator transformer receives the output power coming from the switch selector, and in the output of the isolator transformer is the power entering into the main breaker of the AC panel. All right, now we are going to do the wiring for that panel. That panel, because this is a double phase boat, have double phase breakers and single phase breakers. There are breakers double phase for air conditioning equipment, for water makers, for some appliance double phase, and there are single phase breakers for blowers, lights, computers, TVs. Those are single phase breakers. Okay, what is the advantage of this configuration? You have two phases. You can create one group of breakers for one phase, the red one, and you can organize other group of breakers for the second phase. And you can balance the load in order to keep both phases working with the same or similar load all the time. What happens if one phase is working with a double load in comparison with the phase number 1? In what situation you know that the system is unbalanced? It's basically when the boat is working with generator. When the boat is working with generator and one phase is full, for example 80 amps, and the other phase is only 20 amps, you hear on the generator the rotor of the generator try to touch the stator. That's not good. For that reason, it's good idea per each phase install ammeter and voltmeter per each phase. When I am going to fit a single phase equipment, I am going to use the hotline and the neutral. Of course, the ground is from the case of the equipment. Hot and neutral for single phase. I am going to fit a double phase equipment. The double phase use hotline, and ground, no neutral. Phase 1, phase 2, and ground, no neutral. The reference in double phase or three phase is hot, ground, or if it's three phase, hot, and ground, no neutral. The neutral is used exclusive for single phase. The donut, if you remember, is a magnet. Half is positive and the other half negative. Positive and negative. And I am going to pass the donut through the hotline cable. That's the hotline cable. Hotline 1 and hotline 2. I am going to use two donuts. One donut for phase 1 and other donut for phase 2. And the end of those cables from the donut goes directly into the ammeter. That's simple. That's the procedure to connect the ammeter. You use the donut, both terminals of the donut to the ammeter, and the donut through the cable. One donut for one phase and the other donut for the other phase. This is the AC switch selector. Generator position, inverter position, or shore power position. Shore power, inverter, generator, and this is the output. This is the switch selector for one position, two positions, three positions, and off. Right? This is the switch selector, AC switch selector. Some people, some technicians, some captains, they prefer, instead of a switch selector with three positions, they prefer three individual breakers with a slide bar. They say, oh, I am going to use right now my boat in shore power. I turn on this one on and the other ones off and off, inverter and generator. No, I want to work right now with the inverter. Okay, inverter on, off and off. No, I want to select right now generator. Okay, generator on, off and off. Yeah. Some people prefer the breakers independent or the switch selector. This is too expensive in comparison with this one. Once again, we have the main AC panel, main breaker, individual breakers. We have the inverter. The input of the inverter is DC power, and this is the output of the inverter, AC power. And we have the short power. The short power connection. This is the outlet. This is the short power card. This is the power coming in, and this is the power coming from the generator. The generator is not connected in this moment. We have a generator, we have inverter, we have short power or short power inverter generator, depending if you use switch selector or if you use individual breakers. And additionally, we are going to connect the ammeter, the voltmeter, and the frequency hertz. Frequency, voltmeter, and ammeter. And in the breakers, in the individual breakers, we have one breaker for lights, other breaker for the battery charger, and we have another breaker for outlets. Those outlets, this is basically an example of the real situation. The ground in this particular case is here. That's the ground bus bar. The ground bus bar goes directly past through the transformer and is interrupted in order to insert the galvanic isolator and continue over there. When you insert the galvanic isolator, remember that episode, the episode related with the galvanic isolator, the capacity of the galvanic isolator in amps should be exactly the same capacity of the main breaker on the AC panel. This is the main breaker, excuse me, this is the AC panel, this is the main breaker, and those are the individual breakers. Okay, the main breaker, the capacity of this breaker, in this particular case, is 30 amps, and the capacity of the galvanic isolator is 30 amps. This one should be equal to this, and also the capacity of this and this should be equal to the capacity of the output breaker of the generator. In front of each breaker, you have one LED. When you activate the breaker, the LED should be on. The LED, for this particular case, for this particular example, is similar to this one. It's an LED, one leg for neutral and the other leg for hot. Okay. All the LEDs, they have the neutrals, the yellow ones, connected to the neutral bus bar. And the hot is connected in the output of the breaker. When the breaker is activated, immediately the LED is on. Because the light, one leg is on the neutral bus bar and the other leg is connected here in the output of the breaker. This is the breaker for the light. Now we are going to turn it, the board, and we are going to check the connection. The LEDs should be connected in the output of the breakers, not in the hot line at the input. Because if you connect here, the LEDs are on all the time. That's not good.